The Ice Ages of Earth Part 1. Tonight, we are going to explore one of the most dramatic chapters in the history of our planet. Not a war, not a civilization, not even a species. Instead, we will examine a force that shaped continents, transformed oceans, redirected rivers, and influenced the evolution of life itself. The Ice Ages. Today, many people imagine Earth as a relatively stable world. Oceans remain in familiar locations. Forests grow where they have grown for generations. Cities stand where humans built them. But Earth has not always looked this way. In fact, throughout its history, the planet has repeatedly entered long periods of cooling, known as ice ages. During these periods, enormous ice sheets expanded across vast regions of the globe. Entire landscapes disappeared beneath ice. Sea levels changed dramatically. Animals adapted, migrated, or disappeared, and the world transformed. To understand ice ages, we must first understand climate. Earth's climate is influenced by many factors: the atmosphere, the oceans, the position of continents, volcanic activity, even subtle changes in Earth's orbit around the sun. These systems interact continuously. Sometimes they create warmer conditions, sometimes cooler ones. Over long periods, the balance shifts. Scientists have discovered evidence of ancient ice ages stretching back billions of years. Some were far more extreme than anything humans have experienced. One of the most remarkable theories describes a period often called Snowball Earth. Hundreds of millions of years ago, large portions of the planet may have frozen almost completely. Ice possibly reached regions near the equator. Imagine a world where tropical beaches did not exist. A world where ice covered oceans across enormous distances. A world that looked more like a giant frozen sphere drifting through space. Fortunately, Earth eventually escaped these frozen conditions. Volcanic activity continued releasing carbon dioxide into the atmosphere. Over immense timescales, greenhouse warming increased. The ice retreated, life survived, and the planet entered a new chapter. This pattern appears repeatedly throughout Earth's history. Climate changes, life adapts, the world transforms, then changes again. The most recent major ice age began approximately 2.6 million years ago. This period is known as the Quaternary Ice Age. Interestingly, we are technically still living within it. That may sound surprising. After all, most people do not see glaciers outside their windows. Yet from a geological perspective, large permanent ice sheets still exist near the poles. Earth remains in an ice age. We simply live in a relatively warm interval called an interglacial period. One such interglacial period is happening right now. During colder phases, enormous glaciers expanded across North America, Europe, and Asia. The scale was astonishing. Ice sheets sometimes reach thicknesses measured in kilometers. Imagine standing where a modern city exists today and finding yourself beneath a mountain of ice. That was reality for many regions. Glaciers moved slowly, a few centimeters per day, sometimes less. But over thousands of years, they reshaped continents. Rock was scraped away, valleys deepened, lakes formed, landscapes changed. Many familiar features visible today were created or modified by ancient glaciers. The Great Lakes of North America provide a famous example. Their formation was heavily influenced by glacial activity. The fingerprints of ice remain visible even after thousands of years. Ice ages also influenced the ocean. As water became trapped within glaciers, sea levels fell, coastlines moved outward, land bridges appeared. Animals migrated into new regions. Human ancestors benefited from these changes as well. At various points, lower sea levels connected places that are now separated by water. Migration became easier. Species spread. Populations mixed. Climate helped shape history long before written records existed. Of course, ice ages were not peaceful for every living thing. Environmental changes created challenges. Habitats shifted. Food sources changed. Species faced new pressures. Some adapted successfully. Others disappeared. One famous group associated with the last glacial period is the mammoths. Woolly mammoths roamed cold environments across large parts of the northern hemisphere. Their thick fur helped them survive harsh conditions. For thousands of years they thrived. When many people imagine the Ice Age, mammoths are often the first animals that come to mind, thanks in part to documentaries and perhaps a few animated films that shall remain unnamed. The real animals, however, were impressive enough without Hollywood's assistance. Massive, adaptable, perfectly suited to cold environments, yet even they could not survive forever. Climate continued changing. The ice eventually retreated, and a new world emerged. But the story of Earth's ice ages was far from over. The clues remained hidden in glaciers, rocks, ocean sediments, and ancient air trapped inside ice itself, waiting for future scientists to uncover them. The Ice Ages of Earth Part 2. By the end of the last major glacial period, Earth was changing once again. The enormous ice sheets that had dominated large parts of the northern hemisphere began retreating. The process was not fast. Nothing in geology is. Year after year, century after century, the ice slowly melted. Rivers expanded. New lakes appeared. Sea levels rose. Entire landscapes transformed. To the people living at the time, these changes would have been difficult to notice during a single lifetime. But over generations, the difference became undeniable. The world was warming. Today, scientists know an extraordinary amount about these ancient climate shifts. One reason is ice itself. Glaciers are not merely frozen water. They are archives. Every winter, snow falls and forms new layers. Over thousands of years, these layers become compressed into ice. Tiny bubbles of ancient air become trapped inside, like time capsules. When scientists drill deep into ice sheets, in places like Antarctica and Greenland, they recover samples that contain records of Earth's past atmosphere. Some of these samples are hundreds of thousands of years old. Imagine holding a bubble of air that was trapped before modern civilization existed, before the Roman Empire, before agriculture, before many of humanity's earliest cities. That is exactly what scientists have done. By studying these bubbles, researchers can measure ancient concentrations of carbon dioxide, methane, and other gases. The ice preserves evidence of climates long vanished. In a sense, glaciers keep diaries. Fortunately, unlike many human diaries, they contain fewer embarrassing entries. The information stored inside ice has transformed our understanding of climate history. Scientists can compare atmospheric changes with temperatures and environmental conditions. Patterns emerge. Cycles become visible. The story of Earth's climate becomes clearer. Another question naturally follows. What happened to the famous animals of the Ice Age? The answer is complicated. Many species survived changing climates. Others did not. The woolly mammoth remains one of the most famous examples. For thousands of years, mammoths thrived across cold northern environments. Their bodies were perfectly adapted for life in harsh conditions. They possessed thick fur, large fat reserves, and specialized features that help conserve heat. Yet as the climate warmed, their habitat began shrinking. Grasslands changed, ecosystems shifted. At the same time, humans expanded into many of the regions mammoths occupied. Scientists continue debating the exact balance between climate change and human hunting. Both likely played important roles. Eventually, mammoth populations declined. Most disappeared thousands of years ago. A few isolated populations survived much longer on remote islands. The last known woolly mammoths lived only a few thousand years ago, closer to modern times than many people realize. While mammoths disappeared, humans adapted. In fact, human history and Ice Age history are deeply connected. Our ancestors survived some of the most challenging environmental conditions imaginable. They endured long winters, migrated across continents, developed tools, created clothing, mastered fire, shared knowledge. Adaptability became one of humanity's greatest strengths. Unlike many species, humans did not rely solely on physical traits. They relied on learning, innovation, cooperation. These abilities helped people survive dramatic environmental changes. Throughout the Ice Age, groups moved across vast distances. Some followed animal migrations, Others explored new territories revealed by lower sea levels. One famous example involves the land bridge known as Beringia. During periods of lower sea level, a connection existed between Siberia and Alaska. Humans and animals crossed this region over thousands of years. The geography of the planet itself influenced migration. The climate helped shape the distribution of entire population. When we study Ice Age history, we are also studying human history. The two cannot easily be separated. As glaciers continued retreating, forests expanded, new ecosystems emerged, agriculture eventually developed, permanent settlements appeared, civilizations grew. The world we recognize today gradually took shape. Yet the influence of ice remains visible everywhere. Many valleys, many rivers, many lakes, even some of the landscapes people admire today, owe their existence to ancient glaciers. The Ice Age never truly disappeared from Earth. It simply left behind evidence. Sometimes that evidence is dramatic: towering glacial valleys, massive deposits of rock, ancient fossil remains. Other times the evidence is subtle: a curved hillside, a polished stone surface, a layer of sediment hidden beneath the ground. Geologists learn to read these clues much as historians read documents. Every landscape contains a story, and often that story includes ice. This brings us to one of the most interesting questions: will another ice age occur? According to natural climate cycles, the answer is probably yes. Earth's orbit changes slightly over long periods. These variations influence the amount of sunlight reaching different regions over tens of thousands of years. Such changes can contribute to the growth of ice sheets. Scientists have studied these cycles extensively. Under purely natural conditions, future glacial periods would likely occur eventually. However, modern climate systems are now influenced by additional factors. Understanding exactly how future climate patterns will unfold remains an active area of scientific research. The details are complex, the timescales are enormous, but the broader lesson remains simple. Earth is not static. It never has been. The planet changes continuously. Mountains rise, oceans shift, continents move, ice advances, ice retreats, life adapts. The story continues. Tonight, when you imagine the Earth, it may be tempting to picture a familiar world: blue oceans, green forests, snow-covered mountains. Yet hidden beneath that familiar appearance is a history of extraordinary transformation, a history written in ice. For millions of years, glaciers shaped continents. They carved valleys, moved rivers, influenced ecosystems, and helped shape the path of human history. The next time you see a photograph of a glacier or a snowy mountain range, remember that you are looking at a small reminder of a much larger story, a story that stretches back millions of years. A story recorded in ice, stone, and ancient air. A story still being uncovered by scientists today. And as Earth continues its slow journey through time, that story is far from over. The ice remembers, the rocks remember, and through science, we continue learning how to read their memories.